Here's an update on the lathe, some of the things that I've been modifying on it. I put, this was the Harbor Freight precision mini lathe. You can pick them up at Harbor Freight. Pretty neat little thing. But it's the same, I'd say respectively, it's the same as a Grizzly. They probably come off the same line, just different paint and stickers. But anyways, I took the ball screw off and the axis carriage there, and put a servo here, put a new ball screw on, and also put a new Z servo for my Z, and just put on this quick change tool post holder. You can set your tools and put a quick changer, boring bars and other tools. Get that off of eBay, very cheap. It's genuine aluminum. There's different ones that are you basically can pay whatever you want for them. I mean, this is, it was like 20 bucks or less, but there's some on there for several $100s. For what I'm doing, there's no need for that. This is just a little small jeweler's lathe, and this will do, absolutely. What I'm going to be driving these servos with is the Gecko. It is the Gecko 540. It's a 4-axis drive. I'm only going to be using 2, so this is overkill for what I'm doing. But in the future, I plan on also getting a mill. And when I do, I'm probably going to build one, and when I do, I can use this on both. I can use this for my lathe or on the mill. So I'm happy about that. I'll definitely use that. So I need to get the wiring. It's stressing me out because you put the wrong wire in the wrong spot and you blow it, and these are not cheap. So I got to make sure I do it right and do it right the first time, because I can't afford to get another one. Got one shot at it, and this is a very good drive. And it actually came from the same place that I got these motors, so they fit each other. These are actually made for those. They just plug right in. That's something you cannot beat, is plug and play. It does not get any better than that. And if you start getting involved in this stuff, you'll understand what I'm talking about. The more plug and play you can do, the better off you are, because this is a hassle. It can get very stressful. Okay, so there's my driver. Here's my power supply. It's a what was it? 48 volt, I believe. I don't remember which one I got. 6.8 amp, 3.4. Anyways, first thing that I did on here is I switched that thing over to 115. The other was 240. You want to do that because you don't want to burn it up. You plug it right into the 110. Get a cooling fan in there and everything. And another thing that I did is I plan on doing threading on this machine, and so I'm going to take all this junk off because I don't need it anymore. Previously, on a manual lathe, let me put this thing up. On a manual lathe, here's my old parts. Here on a manual lathe, anybody familiar with that knows that you got to clock it on the dial. And every time that you go back to proceed into the cut on a thread, you have to clock it on the same number. Or if you were on an even number, stick to even. If you were on odd, you have to stay on odd. And it can be a pain in the ass, because if you miss it, then you take a chance of splitting your threads. That sucks. So I'm getting rid of this, and I'm going to this. It's really nice. It's 3D printed. If you need information on where to get this, I can hook you up with a really cool guy give you a really good deal on them. They're very cheap, very cheap. And but anyways, what this does is it hooks onto here. It bolts right on. Doesn't get any better than that. Bolts right onto there, and it clocks your spindle, so it keeps time to it. So whenever you're on your software, I'm going to try to use Mach 3. And so when you're using your software and you're wanting to do threading, this does the same as you were doing with the manual side, clocking it. You know, you're staying on the even numbers or odd numbers. This is the same thing. It keeps track of that for you. So you don't have to do that no more. So you just mount that on there and it does it for you. That's so much better. So much better. Now here's on that quick changer tool post, they give you all kinds of little goodies. You got tool holder. Different types. Turning tools, hard off tools, whatever tools you need. I'm really excited about this. If you're going to convert it, you better get something going on this, and I recommend this. I haven't tried it yet, but I've watched a lot of videos, and I'll look at myself. I've watched a lot of videos on it, and this is going to be the simplest way to go. Nice and 3D printed. You did a really good job on it. This actually, saw exposes the components. You did a really good job. Super glued on or whatnot. Throw that in that box. That's my lathe so far. I'm gonna use this parallel to USB, and I'm gonna plug the parallel into here, and then the USB into my laptop. That's what I'm hoping to do. I'm hoping to be able to drive it that way. Time will tell. I'm not for sure how it's all going to work out, but that's my hopes, and I hope it works. So I got to get the wiring up my drivers and my power supply, and get my software installed, and get to trying to get this thing cutting some metal, or plastic, or whatever I can find to do. Tighten that up. I just hand tighten that on there. This thing just so cool, so much better than the other. This is the other, and you see, I'll show you. Let me take this off. Previously, you guys have them on there, and you put your tools in here, and let me grab it to you. You can see high speed steel. I'm trying to go to carbide, and you know, kinds of them. These are the Harbor Freight ones that you can buy from Harbor Freight. They're all right, but if you're gonna do it, I'd recommend high speed steel, and shape your own tools. Learn it. You don't know how to do it, learn it. That's all I can say. If you don't want to learn it, you shouldn't be doing this. I mean, that's all there is to it. But anyways, those tools get mounted in here, and that was the old way, you know. And every time you run your part, like say for instance CNC, if you were using this block, then you would turn your tool, turn your part, and if you were going to, say for instance, drill or bore it, you would have to touch off your tool. Well, doing away with that and putting this in here, you still have to touch off your tool, but you touch it all off in the beginning of the program. So say for instance, right now if I had a turning tool in there, I would go ahead and touch it off in my X and Z, and then I would take it out, put in my other tools that I would be using, set them in there, lock it down, touch them off, and once I got everything touched off, all my tools that I'm going to be using for the specific job, then I would start with my first tool and run it. And every time I changed the tool, I wouldn't have to touch anything off. All I had to do is just take it out, put the next tool in, and hit start, because it's already been touched off and it can go ahead and cut. It's amazing. It's the most easiest and simplest way to go. You will save so much time. If you're doing production or anything repetitive, that is the way to go. Or if you've modeled out stuff and you've wrote your code and it's all proven, and you know it's all laid out in front of you and you know exactly what you're going to do, this is the way to go. But if you're just flying by the seat of your pants and you're doing, that's manual stuff. If you got an idea in your head and you're trying to make it, here's the way to go right here. All CNC. Model, get a computer, get it modeled out, slap it on the lathe, get the tool post, get it done. Thanks for watching.